In this video, we are going to learn about calorimetry. At the end of this topic, students should be able to A. Define heat capacity and specific heat capacity. B. Calculate heat change in simple and a bomb calorimeter. And C. Calculate the heat change in a constant pressure calorimeter. 2.2a Calorimetry. Heat changes in physical and chemical process are measured with calorimeter. Heat capacity, or a capital letter of C, is the amount of heat required to raise the temperature of a given quantity of the substance by 1 degree Celsius, and the unit is joules per degree Celsius. While specific heat capacity, or the small letter of C, is the amount of heat required to raise the temperature of 1 gram of the substance by 1 degree Celsius, and the unit is joules per gram per degree Celsius. Maksudnya dekat sini, kalau kita ada substance yang kita tak tahu mass dia, kita hanya boleh ukur heat capacity, iaitu heat yang kita perlukan untuk tingkatkan temperature dia by 1 degree Celsius. Tapi kalau kita ada mass untuk substance tu, kita boleh ukur specific heat capacity, iaitu amount of heat yang kita perlukan untuk tingkatkan temperature untuk 1 gram substance tu by 1 degree Celsius. So, kalau heat capacity, simbol dia C besar, unit dia tak ada gram. Untuk specific heat capacity, simbol dia C kecil dan dalam unit dia ada per gram. Itu beza antara kedua-dua ni. The basic principle of calorimetry is heat absorbed equal heat release. The quantity of heat Q can be determined by using one of the following equation. Q equal capital C delta T using C as heat capacity, or Q equal M C delta T when C is specific heat capacity, while heat of reaction or enthalpy delta H can be determined by using the equation delta H equal Q over number of mole. An example of a simple calorimeter is a polystyrene cup. The equation to calculate the heat change Q is equal to M C delta T. While a bomb calorimeter has a more complicated structure. When a bomb calorimeter is used, heat is absorbed by both water and metal parts of the calorimeter. So, heat released by the fuel is equal to the heat absorbed by water plus heat absorbed by calorimeter. To calculate Q, it is equal to MC delta T for water plus MC delta T for calorimeter. Example 1. Calculate the amount of the heat release from the reaction which is carried out in an aluminium calorimeter with a mass of 3087 gram and contains 1700 milliliter of water. The initial temperature of the calorimeter is 25 degrees Celsius, and at the end the temperature increased to 27.8 degrees Celsius. Given the specific heat capacity of aluminium, water and water density. To solve this question, first of all, we list out all the information given in the question. We know that for a bomb calorimeter, heat release is equal to heat absorbed by water plus heat absorbed by aluminium calorimeter. And from the information in the questions, we have the mass of water and the mass of aluminium. So the formula used is m small c delta T for water plus m small c delta T for aluminium. Substitute the formula with the information and we will get the final answer is 24.7 kilojoule in bracket heat release. Example 2. Read the following questions. As usual, we list out all the information given in the question. If we look at all the information given, we have mass of water, but we don't have the mass of calorimeter. So, heat released by the reactants equal heat absorbed by the calorimeter plus heat absorbed by the water is represented by the formula Q equal capital C delta T for calorimeter plus MC delta T for water. So dekat sini disebabkan soalan tak bagi mass calorimeter, so formula untuk calorimeter kita hanya guna C besar darab delta T, bukannya MC delta T sebab tak ada mass. Untuk water pula, disebabkan dia bagi mass water, kita kena gunakan formula MC delta T. So nampak perbezaan dekat sini. Kalau soalan bagi mass, kita guna formula MC delta T. Kalau dia tak bagi, kita guna C besar darab delta T. Then substitute all the information into the formula and we will get the value of Q is 14721.9 joule or 14.7 kilojoules in bracket heat release. To convert this value into kilojoule per mole, we are going to use the formula delta H equal Q over number of mole. If you read the questions, this reaction is about formation of water. So, the number of mole of substance that we are going to use is the number of moles of water. By referring to the balance equation, the number of mole of water is equal to the number of mole of hydrogen. Hence, 0.1 gram of hydrogen divided by the molar mass, we will get 0.0496 mole. So, delta H equal 14.7 divided by 0.0496 and we will get the final answer negative 296.37 kilojoule per mole. The negative sign is written to show that this reaction is an exothermic reaction, which means heat is released. Alternatively, you can write heat release in bracket next to the positive value. That's all for this video. Thank you.